Experiment 16 involves the use of melting points to identify organic compounds. Unlike inorganic compounds, which oftentimes are very high melting, 700 or 800 degrees sometimes, many organic compounds melt less than 100 degrees centigrade. That means that we can use a boiling water bath to carry out the melting of these substances. In part A, you'll calibrate a thermometer. All laboratory thermometers have some sort of error associated with them. If you had a very expensive thermometer, probably wouldn't have any error associated with it, but typically lab thermometers do have a small error. And so what you'll do is to take 3 substances and melt them. And we have literature values for the melting point of those substances. That would be the correct melting point. And then what you'll be obtaining are the measured melting points. And so working with this first substance, you obtain its measured melting point, and to construct a graph so that we can calibrate the thermometer, you would come up with a hypothetical line from the correct melting point and go across with a hypothetical line from the measured melting point that you observed. Where those 2 lines intersect, we'd put an X. We'd use that same procedure for compounds 2 and 3. Then we'd draw a line that best fits, a straight line that best fits those data points. That would be the thermometer correction. And when you use the graph, we'd almost do it in reverse. Now you'd be obtaining a measured melting point. Say that you had an unknown substance. You obtain its measured melting point, and you come across with a hypothetical line until it intersects the graph, and then come down, and that would be the corrected value. Let's look at the effect of impurities on melting points. Pure substances typically have very precise melting points. And if this is the crystalline structure and it's a pure substance, we know that it's the attractive forces that are holding these lattice points together. And when it melts, there's enough energy that these attractive forces are being broken down. And so if it's the attractive forces holding it together in the solid, if we introduce some impurities represented by X's here, maybe the attractive forces now are less between those dots, and this impurity would lower the melting point. Well, that's a very simple view of what happens, but sometimes melting points of solids are lowered so much by an impurity that the sample actually melts. Here's some typical data. If I had a pure substance that had a melting point of 58.7 degrees, recording the value to the 10th is what you should do. And then I mix some impurities with it and take another melting point. I might find that the new melting point has been lowered 10 or 20 or even more sometimes degrees centigrade, 46.2 in this case. Well, we'll use this fact that impurities lower the melting point of a pure substance to identify an organic substance. In part C, you'll use an unknown and identify it as one of 9 possible compounds. The very first thing you do would be to obtain a melting point of the unknown, and it'll fall within one of these 3 ranges. And let's just say that your melting point melted somewhere, your compound melted somewhere between 62 and 72 degrees. So we've ruled out these 3, I've ruled out those 3, but I don't know which of these 3 compounds my unknown is. And what we'll do next then is to mix some of your unknown with A. In a separate sample, we'd mix some of your unknown with B and some of your unknown with C and carry out those 3 melting points. Well, here's some typical data down here. Let's say that your unknown melted at 65.2 degrees centigrade, and here's the data that we obtained. In one case, when I mixed it with A, the melting point was greatly lowered. Well, I know my unknown is not A. A was acting as an impurity, and lowered the melting point. B, though, hey, that's a possibility. I mixed my unknown with B, and it's almost the same. And C, I've mixed my unknown with C, and again, the melting point has been lowered by 10 degrees in this case. So I have a lot of faith that my unknown is compound B. And you'll use that technique to identify your unknown.